Right, I've ordered all the pipe work, valves, all swage rock pipe work for the modifications I'm going to do to this, but they're not here yet, unfortunately, so there's not much I can do on Jodie B at the moment. I obviously haven't got another submarine to work on. Look, I'm still getting used to for it not being here, actually, a bit weird. So I did start making this thing, which is just a little clamp to fit around the forks of the bobcat, just to hold it, hold the forks in an upright position when I'm driving. Bit of boring thing, so I haven't got any more. I forgot to order some 10mm steel for that, so I haven't got any of that. I've got a customer thing to do, I'm going to do now, which is so boring I'm not even going to mention it. But what I am going to do is this I-beam here. Where is it? Can you see that? There, yeah. This I-beam, I'm going to model this up and test it because I want to test some more of the simulation package. I mean, you can see that I just cobbled this thing together, but it would be nice to actually see how much it genuinely will take. So I'm going to model this up tomorrow and let's see how it looks. Sit up, sit up, sit up, stay, 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 stand up, stay, stay. To me, to me, to me, to me, to me. Well done.
Right, so I'll just show you a couple of more things I've been doing with CAD now. What I've actually done here is, go back to design mode, I've been modelling the crane gantry thing just to see, just to try and get to grips a bit better with the software. So you can see here's the actual thing. I haven't gone to too much trouble with it, but it's to dimension anyway. And if I go into the simulation mode now, this one, I did one with a 2-ton load in it, but I can't seem to have found the results. They seem to have disappeared. So anyway, load case 2, the force applied is there. Oh, not 2 faces. What's happened there? I don't want that. The force is acting right just there on that bolt, and I've put 1-ton force, which I'm assuming that they're meaning metric. So quick Google, we could do it in kilonewtons, but leave it at 1-ton force like that. And the constraints I used were the two bottom pieces there, so that's it sitting on the floor. And then if we look at the results, which I've already run, so we don't have to wait for it. Let's have a look. Results. So what's we going? Safety factor. It just shows you sort of an exaggerated view of it, but basically this is 1 ton on it, and it's going to fail there in the red zone. So that's a bit disappointing. I thought it would take more than that. That's stress. Displacement is a good one. Then you can see how it actually does it. This is quite good. And it's quite surprising. It actually bends, buckles on the legs. So I kind of thought it would just bend, buckle at the top. Anyway, that's the point. And I think that's about right. That is a 1-ton load, so it can't take that, which is, like I said, disappointing.
Touch your chain. Yes, well done.
And I'm doing it at 292 psi, which is 200 meters of depth. And I'm going to hit solve. Now it's moaning because there's no structural constraints, but I've switched that off because there aren't any constraints on this. Nothing is grounded. It is a floating body. Solve. Go. Right, and this takes a bit of a while, so I'll spare you waiting for that. So let's have a look at the results. So this says it said marginal, so its computer thinks that this one isn't quite right, and it's showing the weak points there in between the rings, which could well be right. So, and there look, are weak points at the end. So let's go for stress results. That's quite interesting. So this one could probably do with some tweaking. I think this would be on the limit, but for 200 meters. But I think these rings need modifying, and I need to also change the material, because in reality it wouldn't be made out of rubbishy steel, it'd be made out of proper pressure vessel steel. So I'm going to do that one next.